28 from OpenStax PreCalculus, we're asked to graph a piecewise function, this specific piecewise function. At this point, you won't be graphing a whole lot. Really, it's just in theory, in the previous section, you learned your toolkit functions, which were constant functions, linear functions, and quadratic functions. So since you now have those down, they can use those to define this piecewise function. Fine. And I guess if you memorize those graphs, maybe you can come up with this graph. And so the way I'm going to do it is I'm going to give you a rough outline here of the graph. Good enough. 1, 2, 3, 4, -1, -2, -3. Hopefully that'll suffice. So what this function does is my graph should look like the quadratic graph x squared, but not everywhere, only if x is less than or equal to -1. So the x squared graph you might remember is the parabola. It's the one that kind of looks like this. But I don't want to draw the parabola. I only want to draw that U-shaped curve everywhere to the left of -1. Since it's less than, +1. Since it's less than or equal to +1, I want to start it here at +1 with an open circle and then draw my U-shaped graph, which I'll try my best to do on a computer, but it's not the easiest thing in the world to do, and throw a little arrow up there indicating that it goes on forever. So what I've drawn right here just takes into account this first rule, which is why I only drew it where x is less than 1, less than or equal to as indicated here. From 1 up to 2, not including 1 but including 2, I want the height to be exactly 3. So here's where the height is 3. From 1 up to 2, I want the height to be equal to exactly 3. I want to draw that graph right there. And then if x is greater than 2, I want to draw my diagonal line. Okay, that's a little bit hard to do because my picture is so screwed up, but I think my diagonal line will go through this point, and then it would look like that. So this right here is kind of what your graph would look like. It doesn't ask you to figure out the domain and the range, but you could. The domain would be all possible x values, which would be everything from -infinity to infinity, and the range would be all possible y values, which it turns out would be everything from 0 up to infinity. We get them all on this half right here. We don't have to worry about all this junk over here. But it doesn't ask you to do that. A nice little solution, give your book some credit, is they break it up into 3 different graphs, which I think is kind of pretty, and then put them all together and come up with the same answer. But now you have the answer both shown with nice graphs and shown with hard to read ugly graphs, but at least they're talked through.